So we've been talking about using or solving three variable systems. So one of the biggest applications that comes in handy, depending on which math class you're in, is being able to create a quadratic equation when you're given your table of values. So if you're just given your table of values, how can you actually put this into your formula? Well, here if we look at it, if we think about it, we have y equals ax squared plus bx plus c. Most people would typically say, hey, you have two variables, y and x. But those are actually numbers that are given to us. So our goal here is to solve for a, b, and c. Well, if we're solving for a, b, and c, then we have three unknown variables, which means that we need three equations. So we can use our table of values to plug it into here to create our three equations that we're going to end up using to solve for a, b, and c. When we go about doing that, this is kind of our big piece. If you have your y-intercept, so x is equal to 0, use it. Use it every single time. It's going to make solving this a lot easier. So I immediately know that this is a coordinate point that I want to use. I could choose any of the other ones to choose, but for today, I just went ahead and chose these three together. So what we're doing is we're actually saying y equals ax squared plus bx plus c, and we're substituting these into this expression. So for the first one, my y value is 17 equals a, well, my x value is negative 2 squared plus b times negative 2 plus c. That gives me, I like putting my y value on the other side, so I'm going to do that. Negative 2 squared is 4. Negative 2 is just negative 2. Plus c is equal to 17. I'm going to do it again for the next one. So 11 equals a times the negative 1 squared plus b times negative 1 plus c. So I'm going to simplify again. Negative 1 squared is positive 1 times a is just a. Negative 1 times b is negative b plus c is equal to 11. And then lastly, this y-intercept. So 7 is equal to a times 0 squared plus b times 0 plus c. You're going to see how cool this is. By choosing the one with an x value of 0, these cancel away. 0 squared is 0 times a cancels. B times 0, 0 cancels, leaving me simply with c is equal to 7. Now that I have a three-variable system and three equations, I can go ahead and solve this. I almost considered using the y-intercept almost cheating because it gives you one of the values off the bat. I don't have to solve for c. I have it, and I can actually plug that into both of these equations to help me solve it. So that's going to be my very first step. That's going to give me 4a minus 2b plus 7 equals 17. If I bring that 7 over, I have 4a minus 2b equals 10. My other one, a minus b plus 7 is equal to 11. And once again, I'm bringing that 7 over, and that gives me a minus b equals 4. So here you have it. I have two equations, two variables, so I can solve these out. I see that for this one, isolating a variable is going to be really easy. So I'm actually going to use substitution for this one. That's going to give me a equals, I'm going to add that b to the other side, so b plus 4. And I'm going to substitute that in here. So 4 times b plus 4 minus 2b equals 10. Don't forget to distribute. 4b plus 16 minus 2b equals 10. Combine those b's, so 4 minus 2 is 2. Subtract that 16 to the other side. And that gives me negative 6. So I get that my b value is negative 3. Now that I have that, I can substitute it into any of my formulas that I want. I'm going to substitute it in here just because it's a little bit easier. So I have a equals negative 3 plus 4. A is equal to 1. Normally, with a three-variable system, now that I've solved this, I plug these back into one of my original ones to solve for c. But here, because I used that y-intercept, I already had c, which is good. So now I can go ahead and just use those as the coefficients in my quadratic. So y equals ax squared plus bx plus c. Now that I have a, b, and c, I can plug them in. So y equals 1 x squared plus negative 3x plus 7. I'm going to simplify that to see what it would normally look like. We don't need a 1 as a coefficient, so it's x squared. I don't typically say plus and negative, that's just minus 3x plus 7. And there you have it. We now know the formula of the quadratic that gave us these points. So you can plug them into your standard form quadratic. That gives you a system where you're solving for those coefficients a, b, and c, and you can solve it out using your method of how do you solve a 3-variable system.